24. Take the number 24, for example. Now, if I told you to list 24's factors, you would say, and I know this seems rudimentary, bear with me, 2 and 12, 3 and 8, 4 and 6, right? And if I said to you, 24 has a factor of 2, what is its other factor? Assuming you did not know the answer to that, you could divide 24 by 2 to come up with the factor that goes with the 2. Am I right? Because obviously 2 times 12 is 24, not any of this other stuff that's in the list. Okay? So that's how division can help you establish factors of something. And bigger numbers, if I said to you, hold on. 272 has a factor of 17. What's its other factor with the 17? Well, you could simply plug in 272, divide it by what that number I just gave you, and you would be able to come up with the fact that the other factor is 16. Those are the two factors, with the 17 being one of them. Now, what we're going to learn about today is some simple division of polynomials and how that works. And I'm going to do as many examples as I can. First, I'm going to start with something simple. And my version of example 1, they've got their example 1. You can do that later. If I say to you 16y minus 12 divided by 2, that is the exact same thing, my friends, as saying 16y divided by 2 and negative 12 divided by 2. So if you are given a polynomial, and that's what this is, and you are asked to divide it, in this case we're cutting it in half, simply dissect each component and divide. 16y cut in half, you guys got an idea what that might be? 8y is right, 8y. And negative 12 cut in half, it's a negative 6. So that's your answer when you're asked to cut it in half. What if I used the exact same numbers, or at least the exact same numerator, but said divide it by 4? No problem, we can do that. We can take 16y, cut into 4 pieces, and negative 12, cut into 4 pieces, and yes, 4y and negative 3 would be your answer. 4y minus 3 would be your answer. Huh? Well, it gets harder. I know, it shouldn't be too bad. But you do have to remember some rules. Definitely are going to need to remember some rules, and that's where, as we continue on, you'll start to see the rules that you need to keep in mind. Take the next example. Can I flip, or are you guys still copying? It's not too hard, I know. Take the next one. Here comes example 2. I'm going to throw some bigger division in, like say 28p times q minus 35p is going to get divided by 7 times p. So to translate this, break that polynomial. 7pq, I'm sorry, 28, I'm sorry guys, I'm really miserable, divided by 7p, and negative 35p divided by 7p. Now here's the place where people start to make mistakes. First, let's divide the numbers. 28 by 7. is what? P divided by P is 1, which basically means it canceled itself out. So P is no longer in the quotient. Q divided by 1, there's no matching Q, means Q is still a part of the answer. You can check yourself to make sure that your quotient is correct by multiplying 4Q by 7P. And if the product of these two things is what you started with, you know you're okay. Continuing over here, 35P by 7P, what do you get? 5. There's your answer. Okay? Let's try another one. Same exact, I guess I could just do a different one here. Just ignore that, please. Okay. Didn't give myself enough room. If I divide both of those pieces by 14xy, it'll look like this. 14xyz divided by 14xy, positive 70x squared y squared divided by 14xy. What's the result going to be here? Z, 1z to be exact. You don't have to write that though. 14 by 14 is 1, x by x is 1, y by y is 1, z, there's no z's to match, so that means z stays in the quotient. Multiply the quotient by the divisor to get the dividend. 70 positive by 14 positive is a positive 5. X to the second divided by x to the first. You guys remember the rules for exponents? If you have the same base, you subtract, which means x. Y squared divided by y to the first. If the exponent's not written, it's a 1. There's your answer. Okay, those are 2 samples from example 2. Okay? Just because they get bigger, that's all examples 3 and 4 do. Just because they get bigger doesn't mean they get tougher. They just take longer. Here's example 3. 4x to the 5th minus 24x to the 3rd y plus 10x squared y squared. All of this is being divided by 2x squared. All of that is being divided by 2x squared. So break it up. And some of you are not going to even rewrite it. Some of you are going to automatically just go this divided by this, answer. Negative 24 divided by this, answer. That divided by that, and you'll just write it out. If that's you, that's fine. For the rest of the universe, 4x to the 5th divided by 2x squared, negative 24x cubed y divided by 2x squared, positive 10x squared y squared divided by 2x squared, okay? Numerically, 4 by 2 is 2. 2x what? Cubed. 5 minus 2 is 3. Very good. Negative 24 and positive 2, negative 12, x, y. Is there anybody that doesn't know how I came up with x, y? x3, x2 gives us x1, y, and there's no y's, so the y just moves down into the divisor, into the quotient. And 5y squared, I think, is the end result. okay? And if I take this and multiply it by that, I'd better get this. Like I said, they don't get tougher, they just get bigger. Yep. Yep. Now, example 4. This is the last thing for today. And then I'll give you the rest of this time to work on the 20 problems. Notice it's odds and evens. If you're smart, you're doing all 20 of them and using odds to verify that you're learning, if you're using your time wisely. Okay, here's the last one I want to do with you guys. All of this divided by 1 RS. Okay? This is a little tricky, just a little bit. Okay, let's do the numbers. 6 by 1 is 6, right? Because since there's no coefficient, the coefficient can be written in as a 1, or you just know it's a 1. 6 divided by 1 is 6. R cubed by R? Anybody? Uh-huh. SS disappeared, right? Okay, negative 18 by 1, R squared R, S squared S. Okay, here's the part that's tricky.
To the office, please.
3 divided by 1, my friends, is positive 3. R divided by R, they disappear. Now, there's nothing matching the S up here, which when it looks like these, if that number is the dividend, it just lays right there in the answer. Whereas if this is in the divisor and there's nothing above it, it's like saying 1 divided by S, just like this is like saying y squared divided by 1. I just haven't described it that way. But 1 divided by S means the S stays in the denominator. We'll do another one. Oh yeah, I like to do all kinds of exciting things around here. You won't see a ton of those, but the ones you will see, I don't want you to feel awkward about.
Fair enough.
Yeah. This is something you will see. All right, I'm going to do one more like this. Oops, B. Sorry, I got a little crazy with my pencil. Okay. Here we go. The first piece is 12ab cubed by 6a cubed b. The second piece is positive 6a squared b squared by 6a cubed b. The last piece, negative 24a cubed b by 6a cubed b. First one, 12 and 6 is 2, right? And a and AAA. So this is like saying A in the numerator and 3 A's in the denominator. That's what this is saying. Okay? 2 of them cancel out, which means A squared is left in the denominator. Why? Because they're left in the denominator. B cubed over B means B squared stays in the top. Same kind of thing here. 6 divided by 6 is 1. A squared, A cubed. That's like saying AA and AAA. So there's going to be an A left in the denominator. Why? Because there's 1 left in the denominator after you cancel 2 of them. B squared B means 1B stays on the top. So it's 1B over 1A. Last one's easy. Minus 4 it is. Okay? This is the toughest type. I don't even know if you'll see that today, but I wanted you to get introduced to it anyway.